We're going to go ahead and take a look at scatter plots and what's called correlation. Now, scatter plot worked with bivariate data. Bi meaning two, variate meaning variables. So we're dealing with two variables. And scatter plots work only with quantitative data. So let's go ahead and take a look at this data over here on the right. We have the relationship for 16 different people between the number of beverages they drank and their alcohol level. Now, we want to kind of figure out the relationship between these two variables. So as we look over here, we're going to make ourselves a scatter plot. Now, most people are going to anticipate that the number of beers should have some type of an effect on the blood alcohol level. So the number of beers is going to go on the horizontal axis, which is your explanatory variable. You're hoping the blood alcohol level will respond to the number of beers. So the blood alcohol level goes on the vertical axis, and that is considered your response variable. So for this particular one here, you had 3 beers, so you want to go 3 units to the right, and your blood alcohol level was 0.07. So you go 3 units to the right, and you go 0.07 up. This one here had 5 beers, and it was 0.1. So you go 5 over, and you go up 0.1. And so on, and you plot all these. And you'll notice for the most part, when you look at it as a visual picture like this, the more beers you have, the higher your blood alcohol level is in general. Is it a perfect correspondence? No, but there's a general pattern of going up to the right. And we kind of anticipated that. Now, your response and explanatory variables, we talked about that a little bit before. Your explanatory variable is your independent variable. You want that on your horizontal axis. You're hoping that this variable here will explain what's going on with this one over here. This variable here responds to this one here, so it's referred to as your response variable. It's your dependent variable. It goes on your vertical axis or your y-axis. Now, not all graphs have a clear response and explanatory variable. Here we're looking at the relationship between calories and sodium. Definitely it looks like there's an upward trend here. So you might think, well, does more calories explain higher sodium? Or is it really higher sodium that explains higher calories? It's really neither. So not all situations have a clear response and explanatory variable. Here's a graph of the relationship between treasury bills and common stocks and their returns. Does one determine the other? Not necessarily. And so here's another example where an explanatory and response is not necessarily clear. So what is our explanatory variable here? Well, our explanatory variable is the amount of our ginkgo that is given to each student. We're hoping that that will help explain what's going on with the memory. When you're looking at bivariate data, and remember bi means two, variant means variables, so two variables, our first step is to always go ahead and make ourselves a scatter plot. Now, what do we do with our scatter plots? Well, we want to look at the overall general relationship of what's going on. Does it go up or does it go down, or is there really no direction? We want to look at the form. Is it a straight line? Is it clustered in groups? Is it curved? Or is there no relationship at all? Now, if it does happen to be curved or linear, how close are the points to that line or curve? That's referred to as your strength. If they are really close to it, we would say it's a strong relationship. If they're somewhat close to it but somewhat scattered out, we would say it's a weak relationship. You also want to look for overall deviations from the pattern, meaning outliers. So now, let's take a look at the top two here. We would consider both of these to be linear. if we draw in a straight line, for the most part, our straight line would go through the middle of our data. We would say this one here would also have a negative direction, negative association. This one would have a positive. If you go up as you go to the right, it's positive. If you go down as you go to the right, it's negative. Now, over here on the right is no relationship. You might say, well, it looks like it's linear. It's a horizontal line. Yes, but a horizontal line has a equation of y equaling just some number, say 5 or 7. And while you're hoping that your horizontal, your x's will explain something going on with the y's, but there's no x here in your equation. This one down here, it's pretty much just a bunch of random points. There's no relationship. Now, as we look over here, here we have kind of a curve going up. And here we kind of have almost a horseshoe. I didn't do a real good job of drawing that. So we would say this first one and the second one are both curved. They're not linear. Technically, the first one is exponential, given to you in this form. The second one is quadratic, given to you in this form. For the sake of this class, we're not really going to consider these here. If you do come across anything like this, you just state that it's nonlinear. Don't be concerned about the ugly-looking equations at the bottom. So we're going to be looking in this class at linear ones, or if they're not linear, we're going to call them nonlinear. So here's some more examples of relationships. Here we have income versus your health status. And for the most part, there's a slightward upward trend here of the higher your income, the better your health status. Here we're looking at age and health status. And you'll notice they're definitely up, but there's really not a whole lot of relationship here. Looking at these two here, we're looking at age and educational level. And you'll realize here that there appears to be kind of a negative association. And well, that's because a lot of the older people were not able to go to college or get as much education as some of the younger people nowadays. And here, there's a definite curve to our pattern. By the way, this one over here, we would look at it and say it's a negative association because you're going down as you go to the right. Technically, here's your positive association. We would also say in this case it's a strong positive association because it's all the points are real close to your line. And you have your negative association. As you go down to the right, it's a negative association. Once again, we had said if it's a horizontal line that it's no relationship. And each one of these would have a horizontal line at about the height of y equals 5. And when you have that, there's no x in it. And once again, when it's a horizontal line, it's no relationship, even though your data is linear. Now, when you're dealing with scatter plots, you only want to make scatter plots out of quantitative data. It does not make sense to use categorical data here. So suppose you had a graph where you had categories on the horizontal and numbers going up here. Well, you might say, well, it looks like a positive association here. But since these are categories, they could really be arranged in any order you wanted. And so then you could arrange them like this, and it almost looks like a negative association. Or you could rearrange them like this one here, and it goes up and then goes down and then goes back up. So when you're dealing with categorical data, scatter plots do not work when you're trying to put categories on your axes. Scatter plots only work when you have quantitative data on your axes and that you're comparing them. Can you somehow use some categorical information within your graph? Yes, and we'll be looking at that later. But your axes and your variables that you're comparing have to be quantitative to be able to find the correct locations on your graph. Let's take a look at the strength. That's how far your points are scattered out from your line. Now, once again, on this one here, all the points are pretty close to this line. We would say in this case it's a positive because you're going up. It's a strong because all the points are close to your line. As we look over here, we would say it's positive because you're going up, but we would say it's weak because all the points are not real close to your line. They're spread out a lot more. So when you're looking at 4 here, and you're trying to use your line to predict what's going to happen at 4, you'll notice you have this one here that's several points above, this one here that's a point below, this one here that's close to it. It's spread out. You have a lot of variability right here at 4. However, over here at 4, there's really only one option, and it's right on the line. So a weak association means that there's a lot of variability at each level. Can you use your line to predict some stuff? Yes, and we'll be doing that in Chapter 5. But when it's a weak, your prediction may not be real accurate. When it's a strong, your prediction would be more accurate. So let's go ahead and take a look at these here. You'll notice in each one of these here, it's a positive association because you're going up as you go to the right. However, this one here, it's a lot of spread out stuff here, so it's a weak. This one over here, all the points are pretty close to your line. Yes, there's some variability, but we would say it is fairly strong in the relationship. Let's go ahead and answer these questions. Well, as you look here, you notice you're going up as you go to the right, so you know it's positive. If I go ahead and draw in a line here, well, I would say it is fairly straight. It's definitely not a big curve pattern or anything, so I'd say it's linear. Question is it strong or weak? Well, since there is a fair amount of variability here, we're going to go ahead. Okay, I guess I was wrong here, but I would say it does say strong here, but I would say it's not overly strong. I would say it's moderately strong, but it's definitely not a very strong situation. This one here, as we look at our pattern, we know it's definitely a curved pattern, definitely not a straight line. If I go ahead and draw in a straight line here, both ends are above, the middle's below, definitely not straight. So we know it's nonlinear. All the points are really close to your curve, so we know it's going to be strong. But it is a positive association because you're going up as you go to the right. Okay, what's going on with this one here? Well, to me it kind of looks like a random cluster of points. Yes, there's some points along the bottom, but there's a peak in the middle. It's definitely not linear. There's really no relationship going up or going down. We would say it's just no relationship. So which one of these two scatter plots has a stronger relationship? Well, since we have this kind of significantly different point, which we would consider an outlier, other than that, the two graphs are somewhat similar, so we would say the one on the right would have a stronger relationship, because if you were to draw in a line going through all these, we would say the one on the right has a stronger relationship because it has no outlier than the one on the left. Here's an example where we actually did go ahead and add categorical data to your graph. You'll notice both axes are still quantitative data, but we have females being the blue, males being the pinkish red. And so then what is our categorical data here? That is our gender. Because remember, our height and our weight are being represented with numbers, so therefore they're quantitative. Now here's an example of 4 different graphs. All 4 of these graphs have the exact same information. But here, all your data is kind of all clustered together in one little area. Here you have a large white space to the left. We don't like that either. Here you have a large white space down below. We kind of want our data to cover up the whole area. So we adjust our axes to have our graph represent the whole area. You want it to kind of cover up all of it. You don't want big white spots. So keep that in mind. And then once again, you can go ahead and add categorical data by using different symbols for each point that you have graphed when you're dealing with your scatter plots.